have discussed about uh, the applications and the operations which will be done on the particular data structures, all the possible operations which can be done on a particular data structures. We have discussed that. And we were just going through the concept of algorithm. So in today's class, we'll just go through what is algorithm and what are the different things we need to know when I consider or when we consider the concept algorithm. So let's see this. An algorithm is a process or a set of rules required to perform calculations or some other problem solving operations, especially by a computer. Okay, so we might have heard in our journey through the computer science courses algorithm. Okay, it is nothing but it is not a big thing to be told about. Okay, it's nothing but it's just a set of rules which you will be following in order to perform a particular calculation. So that is an algorithm. So for example, if I say solving the Rubik's cube, okay, you all might know what is the Rubik's cube. So solving the Rubik's cube, they say to solve the Rubik's cube, you need to know a certain algorithms. So how will you know that there is a certain algorithms? Okay, what you mean by algorithms there? Nothing but each step which you need to follow to get into a goal. Correct? Your goal is you are aligning all the colors in that Rubik's cube into an proper manner. You want to arrange it. So that's nothing but the calculation you're going to perform there. It's not in calculation, but you want to reach to a goal. To reach to a goal, certain steps are to be followed one after the another. Okay, if you miss out one step, it won't give you or it won't allow you to reach to that particular goal. So that's nothing but algorithm, a set of rules, a step-by-step procedure. Okay, yeah. So especially by a computer, if I want to solve something, you will always follow an algorithm. Okay, yeah. So the formal definition of an algorithm is that it contains the finite set of instructions which are being carried in a specific order to perform the specific task. So there is an order also. Okay, if you miss out that order, what happens if you miss a step, or you don't miss a step, but what you do is instead of doing the step now, you're doing it later. So it won't actually perform your task very well. So there is a specific order in it. So it is not okay. Now, in terms of code, if I come, how a algorithm can be what viewed as. So it is not the complete program or the code, whatever we write, but it is just a solution of a problem. I have a problem. I want to solve it. So to solve that problem, I need certain rules to be followed, and nothing but that is the algorithm. Okay, and this solution of a problem can be represented either as an informal description. Okay, it's not a formal description, informal description, like for example flow charts. So we used to discuss this about like flow chart is nothing but the step-by-step rules whatever we have, we will be drawing it in the form of visual manner, that is we call it as a flow chart. So the flow of a particular algorithm we will be putting it in a flow chart, or else we can also put it as a pseudocode. Okay, now here the pseudocode means it's not a code, complete code. Okay, and it's not the informal description also, it is a half code. Okay, the code means it is written somewhere in the normal English itself, but your operations, your symbols which we use in the programming language won't be there. Like the syntax, for loop, while loop will be there, no? So those things won't be there in the pseudocode, but it will be just saying that whatever we do in the for loop, right? For example, I'll be writing for I in range in Python, or in Java itself, if I take for I equal to 1, I less than, and I plus plus. So instead of writing that, why exactly I will be writing that for loop? Okay, if I want to iterate through the elements of the array, so that was my what plan to have that for loop. So when I have the for loop, it would be considered as a code. But in pseudocode, I won't be considering this code, but instead I would be considering the pseudocode. So pseudocode means the false code. False code means I'll be writing the description of what that for loop is going to do. Okay, so if I write a pseudocode, it won't describe that whether you are using a while loop or for loop. but based upon the use case, you have to make sure that which loop you have to use. So that is pseudocode. Okay. So once after learning what is algorithm, next we will see what are the characteristics of an algorithm. So like if I say I have an algorithm, so what are the different things it will be having? So first thing is input. Okay. So an algorithm has some input values, because on these input values actually the algorithm will be performing. So an algorithm has some input values. We can pass 0 or some input value to an algorithm. Output, and one more characteristic is that input will give you an output. Okay, an input will give you an output. So we will get one or more output at the end of an algorithm. So I may give 0 or some amount of value to an algorithm. And algorithm means it is a step-by-step procedure which will perform some operation on the input, whatever I give. And after that, I can expect some or more output at the end of an algorithm. And the next characteristic of an algorithm is unambiguity. So an algorithm should be unambiguous, which means that the instructions in an algorithm should be clear and simple. So whenever I write an algorithm, okay, this algorithm can be a flowchart or also in pseudocode. So as I told, in a pseudocode, I won't be mentioning you use for loop, you use while loop. So the things needs to be very specific and clear, like it shouldn't be unambiguous. I mean, it shouldn't be ambiguous. Ambiguous means it shouldn't be like one sentence having multiple meaning. Okay, so it shouldn't make confused. The people who are looking at that particular algorithm shouldn't be feel confused. Okay, so that is, an algorithm must be unambiguous. Next thing is finiteness. So it's not like when I develop an algorithm, or it's nothing but when I develop a step by step things to be performed to achieve to a particular goal, it will be having infinite steps. Okay, there are more steps to perform. It is not having end. It is a never ending step. If there is there, it is not a proper algorithm. So the main characteristics of an algorithm firstly is that it needs to be finite. Okay, the finiteness. So an algorithm should have finiteness. Here, finiteness means that the algorithm should contain a limited number of instructions. Okay, that is, the instructions should be countable. So it's not like that it is a never ending instructions are given to you to go to a particular goal. You will never reach that goal. Okay, so an algorithm always it needs to have a finite number of instructions. Next, what we have is the effectiveness. Whatever we write, it needs to be effective. So an algorithm should be effective as each instruction in an algorithm affects the overall process. Okay, the each step in an algorithm will affect. So if you miss out one step, it's a problem. Next is language independent. So the main characteristics of algorithm is that whatever code I write, okay, I'll be giving you the step by step process to make you reach to a particular goal. But uh, when I write an algorithm, it's not like you have to implement it in using Java program only. You have to implement it in what other programs, C or C++ programs only. It's not like that. Okay. Apart from that, an algorithm will have language independent. It is not like it will be written over a particular language, over a particular language. So it's written generally, and using any programming language, you can implement it. So that is one of the main characteristics of an algorithm, that is language independent. So what this language independent means, an algorithm must be language independent so that the instructions in an algorithm can be implemented in any of the languages with the same output. Okay, yeah. So whatever input you give, you will get every time you will get the same output in whichever program you executed. Okay, in whichever language you implement the algorithm. So that is language independent. So these are the characteristics of an algorithm. So an algorithm will have an input. It will give you a set of output after performing operations according to the algorithm. Then it will be unambiguous. Then the finiteness should be there, and it will be language independent. Also, the effectiveness makes the main characteristics of an algorithm, because if an algorithm if we need an algorithm, then it has to work in an effective manner. Okay. So the next thing is the data flow of an algorithm. So we have understood what are the different characteristics of an algorithm. Now we'll see how the data is flowing in an algorithm. What is the flow of the algorithm? Okay, the step one after the another. First, what will be there? Next, what it will go to. Then, what it will lead to. Okay, so that we will see. Just give me a second. Okay, so next is data flow of an algorithm. Problem. Okay, so first thing, as we see in this diagram, the first thing is the problem. Okay, why you need an algorithm? Because in the real life, I will be having a problem. I have to find a solution. I want to derive a solution for it. So to get a solution to actually to work on that particular solution, okay, or to get it to solve that problem. Okay, to solve that particular problem, we have to follow some steps, which is nothing but given by the algorithm. So the first thing is problem. Okay, so a problem can be a real world problem or any instance from the real world problem. Okay, for which we need to create a program or the set of instructions. So, but this set of instructions will be known as algorithm. Okay, problem is there, you need to find the solution. So while going towards the solution, you have to, or to get the solution, you have to perform some set of tasks, and these instructions will be considered as the algorithm. Now next thing is algorithm. Whatever algorithm you build, so an algorithm will be designed for a problem, which is the step by step procedure. After that, you'll be having initial problem. To solve the problem, you build the algorithm. After that, we put the input. Okay, so after designing an algorithm, the required and the desired inputs are provided to the algorithm. Then actual processing will start. So next, this inputs will go into the processing unit, which is nothing but the input will be given to the processing unit, and the processing unit will produce the desired output. So the output is nothing but the outcome or the result of the program. So the steps will be there in the algorithm. We will be writing the code, which will be processed in the processing unit part, and then we will be getting the output. So this is the data flow of an algorithm, how the data flow. Okay. Okay. Now next we will see why exactly we need these algorithms. Okay. Just just like that, if I implement a particular solution for a problem, isn't that enough? Why we need this step by step procedures and all? Why actually we need to plan? Why we need this algorithm? So the first thing is scalability. It helps us to understand the scalability. Means when we have a big real world problem, we need to scale it down into small steps to easily analyze the problem. Correct? So that is why I will be now, for example, if I want to climb up the stairs, okay, I want from the ground floor, I want to reach to the first floor. What I have to do, can I fly just like that? No, it's not possible for me, right? So what I do is I'll take one step after another, one step after another. Okay, thereby I will know the problem of climbing to first floor, second floor, third floor. Okay, so in the same way here, whenever I have a real world problem, I will first put it into a small steps. Okay, so I'll first break it down into small things, and in each steps I may encounter some problem, and I'll first solve that, then I'll go to the second part, and then I'll solve the parts, or then I solve the things. Okay, so that's how it will help us in having the scalability of a particular problem. I mean, to solve the problem, whatever solution you give, it will be scalable. Second thing is performance. So the real world is not easily broken down into smaller steps. So if the problem can be easily broken into smaller steps, means that the problem is feasible. Okay, the problem we can put into the smaller steps, but that that's not an easy task. Okay, so if a problem is can be put into a smaller steps easily, that means it is the problem is feasible. So thereby you can also improve the performance of that particular solution, whatever you're building for a particular problem. So Now let's understand the algorithm through a real world example. So suppose we want to make a lemon juice. Now algorithm as a tool, it's nothing but a step by step process, correct? So if I want to make a lemon juice, what are the steps needed? So as shown here, there are 7 steps to be followed when you want to make a lemon juice. So if you are a person, you don't know how to make a lemon juice, okay, so we will provide them the steps saying that for your problem of not knowing how to do the lemon juice, you will be having this set of steps to be taken, okay, to get into your uh, okay, to get into your solution, okay. Yeah. So what is first one? The first thing is, first we will cut the lemon into half, and then what is the second step? We squeeze the lemon as much we can, and we take out its juice in a container. After that, we'll add 2 tablespoons of sugar into it and then stir the container until the sugar gets dissolved. Then, when the sugar gets dissolved, we add some water and ice in it. So, these might not be the steps which everyone follows. Okay, I may follow the different steps. I may take the water first and put lemon juice, sugar in it, everything I'll be doing. Okay, so different persons will have different approaches of solving a particular problem. So out of that, this is one type of algorithm what we can include while preparing a lemon juice. Got it? Yeah. So in the same way, when I have real world problems also, when the people come to me with the problem and I have to provide the solution for them, or I want to build a software for them, okay, I will have a particular logic, and I'll build a logic and I'll build a software. I will have one motto, and I'll have one particular steps which I'll be following. In my team itself, another developer may have another views of what getting a solution for a particular problem. So we both sit together and will think which will be very feasible, okay, which is very scalable and which will performance in a very good way. So that particular program, I mean that particular algorithm, we would take into consideration. Okay, so that's how an algorithm will be built. Okay. Now, this is one example for the real world case of a general case. Now, if I take an example of, okay, yeah, so here we have this. Yeah, the above real world can be directly compared to the definition of the algorithm. So we cannot perform the step 3 before the step 2. We need to follow the specific order to make a lemon juice. Okay. An algorithm also says that each and every instruction should be followed in a specific order to perform a specific task. But in this case, as it is general, I may have different views. Okay. But again, now if I take one more example of an algorithm in the programming, okay, like this algorithm is nothing but to add 2 numbers which is being entered by the user. Okay. So first of all, what is the step one? We have to start the things. Then step 2 is you declare the 3 variables. And always, I don't know if you remember whatever we have learned in the lower classes. So when we have learned in the lower classes in third standard or fourth standard, they do teach us algorithms. Okay, and there we will be drawing the flow charts like the circle, rounded oval will be for start and stop. Then other symbols would be for, like for processing you will have one more symbol. Okay, for input output you will have one more symbol, like parallelogram kind of symbol you will be using. Okay, so everywhere we know that the in algorithm, if I'm actually officially writing an algorithm, we would start with the start and then we would stop with the stop, correct? Start and stop. So the second one would be you have to declare the 3 variables a, b, and sum. Okay, and so this is not a code, correct? If you execute this one, you won't get any output. What is this? This is just a step what you have to do. So these steps, sir, you can now, if I write something like this in the form of algorithm, okay, this is actually a solution what I'm building to add 2 numbers. So using this as a direction, okay, I can implement it in any language to get the output, correct? So what is the first step? You declare three variables, A, B, and sum. A is to store the one number, B is store the second number, and sum is to store the addition of those two numbers. After that, we have to enter the values of A and B. Okay. So means the user has to enter the value, correct? So user will enter the value. Then after getting the value and storing it in A and B variable, it will add the values of A and B and store the result in the sum variable. Okay, that is nothing but sum is equal to A plus B. Once you get the value which is stored in the sum variable, you just print the sum and you just stop over. So this is algorithm, correct? In case of the programming. Okay. Now, so that's how our algorithm will look like. And why do we need algorithm? It will just increase the scalability and the performance. Okay. Now, next we will see about the factors of an algorithm. So there are some factors which you need to know about the algorithm. Now let's see one by one. First thing is modularity. As I told, one big problem, if I divide it into smaller versions of it, it's very easier for us to solve it, correct? So in the same way, when I write the things in step-by-step procedure, if even if case anything happen in one particular step, I can solve it in a proper way, and then I can. So that's called as modularity. When you break the problem into smaller sections, we call it as a modularity. Okay, so if any problem is given and we can break that problem into small modules or small steps, which is a basic definition of an algorithm. Okay, so algorithm means what? We There is a problem, we need to find a solution, so we write a step by step procedure for it or the set of instructions for it. So that is nothing but the modularity. So it means that this feature has been perfectly designed for the algorithm, correct? So modularity is nothing but is another version of an algorithm. Okay. Second thing is the correctness. So the correctness of an algorithm is defined as when the given inputs produce the desired output, which means that the algorithm has been designed algorithm. Okay. So the analysis of an algorithm has been done correctly. So the thing here is the correctness of algorithm is nothing but we would develop an particular algorithm so that in the data flow of an algorithm we have seen while developing the algorithm itself we think what should be the output, so according to that we will be writing the algorithm, the steps, and then you will be what also we will be planning that once you execute it how many outputs are going to come. So if we have seen the earlier code, we have seen that outputs are two. When two outputs are inputs are two. When two inputs are added together, you get one variable, which is the output. So when you give proper inputs and that produce the desired output, then we say the algorithm is correct. So for example, for add two numbers in the algorithm, what you write is subtract A and B. So what the developer will do, the algorithm has written subtract, so that was by mistake. Then that particular person will write A plus instead of A plus B, he will write A minus B. So which will be an error, right? So what input we have given is correct, but the expected or the desired output is not being produced. So that is why the algorithm is not correct. So when I consider the factors of an algorithm, the correctness of the algorithm is very important. Next thing is maintainability. So here maintainability means that the algorithm should be designed in a very simple structured way so that when we redefine the algorithm, no major change will be done in the algorithm. Got it? As I told you, step by step, we are having modularity. Nothing but a problem is divided into smaller steps. Now, when we do it, okay, we have to always make these steps in such a way that whenever I want to make small changes to a particular step, it shouldn't give me a much of a work to that particular step. Okay. So the thing is, how much ever you can just make it modular, okay, that much you have to break it down. So when you make changes, when you redefine the algorithm, no major change will be done in the algorithm. So the maintainability of the algorithm needs to be very important. Next thing is a functionality. So this is the main thing. If you're building an algorithm, if you're writing an algorithm, but it is not functioning properly, it's a waste. So it considers the various logical steps to solve the real world problem, that is functionality. And next thing is robustness. So robustness means that how an algorithm can clearly define our problem, okay, whether it is right or wrong. So that needs to be robust, whatever algorithm we build. And yeah, so the sixth one is we have user friendly. If the algorithm is not user friendly, then the designer will not be able to explain it to the programmer. Got it? So a particular algorithm is being designed, okay? But this designed algorithm is not user friendly, means a person cannot understand it. Even that person who has written all the steps only, he cannot understand it when while explaining it to a programmer. Because once if you plan a step that needs to be conveyed to the programmer, so he can convert it into the form of code and we can execute it and we can get the solution for a problem. So it needs to be user friendly. And the thing is, next thing is simplicity. So as much as simple your algorithm needs to be, it need not be complex. So if whenever it becomes complex, your time complexity, your space complexity, everything will be more there. Because when it is difficult to understand, a person who is actually building the code, I mean, the programmer, if he looks at the algorithm, he didn't understand it properly and it was very complex, he would write some other code which will increase the overall complexity. So, always while building an algorithm, we need to follow the simple steps. It needs to be very simpler in all the terms, in terms of memory and in terms of the time taken to execute a particular algorithm. Next thing is about the extensibility. So if any other algorithm designer or programmer wants to use your algorithm, it should be extensible. Means we have to use that algorithm, and also while using it, I can add some extra things to it. I can extend the very same algorithm which someone else have written. So algorithm needs to be in that way. So these are the factors of an algorithm. It includes modularity, correctness, maintainability, functionality, robustness, user friendly, simplicity, and extensibility. So we have seen what is algorithm, what is the need for algorithm, the characteristics of algorithm. Okay, the performance and scalability was the need for the algorithm. Then we seen characteristics like input, output is there, unambiguous, then finiteness, then the effectiveness. So, okay, means the efficiency. Okay, efficient, and then we have seen the language independent also as a part of characteristics of an algorithm. Then we have seen the data flow of an algorithm, like a problem will be there, we develop algorithm, we give input, it goes to the processing unit, and it will be at the end, it will be giving us the output. Then we have seen about the factors, correct? Factors of algorithm. Okay, so these are the factors of algorithm. The next thing is the importance of algorithm. Okay, now I have an algorithm. Okay, it has two aspects. One is the theoretical aspect, and one is practical aspect. So the both the how what is the importance in both the sides for a particular algorithm? Okay, so in a theoretical importance, what I can say is when any real world problem is given to us, and we break the problem into small modules. To break down the problem, we should know all the theoretical aspects. Okay, so that is very important. That means when I build an algorithm, they told that these are the characteristics. Okay, these are the factors you have to think. This is the data flow of an algorithm. So these are all the theoretical parts of an algorithm. Okay, so we need to know all of these when before you break the problem into small modules, because one thing we have seen that it needs to be extensible and it needs to be simple, it needs to be user friendly, and also we have seen that it needs to be maintainable, and also it should be functional. So when that is the case, I have to break down the things into small modules in an efficient way, because maintaining an algorithm is very difficult. If I want to make some changes, it needs to be easily made. Not much of the changes need to be made when I make a small changes to it. When I actually want to make small changes in it. Next thing is the practical importance. So as we know that theory cannot be completed without the practical implementation, correct? So we know all the theories, but when the practical implementation comes, so the importance of algorithm can be considered as both theoretical and practical importance. Okay. Next, when I build the algorithms, what are the issues can be coming? So one thing is how to design the algorithm. So as we know that an algorithm is a step-by-step procedure, so we must follow some steps to design an algorithm. And second one is how to analyze the algorithm efficiency. Okay, so only when you analyze, you know how to analyze the algorithm efficiency, how well your algorithm will work, what is the efficiency, what is the performance of your algorithm, how much time it takes, how much space it takes. That is the main thing. So that is the issues of algorithm. Okay, now next we have some of the approaches of algorithm. So far we have seen what is an algorithm, uh, okay, how an algorithm works, what is the data flow of an algorithm, what is the need for the algorithm, okay, what are the characteristics and what are the factors, the importance, the theoretical and the practical importance, what are the issues coming regarding the algorithm, those we have seen. Now next thing is to build an algorithm. Okay, like we have seen here that one of the issues is how to design the algorithm. So there are many different ways or different approaches of actually designing an algorithm. Okay, algorithm is nothing but a step by step process. So to achieve to a solution, we make some step by step processes. So that is nothing but what the approach what you have to solve a particular problem. Now we have the approaches of an algorithm. Okay, so the first approach, okay, we have many different approaches of the algorithm. So the first approach would be brute force algorithm. So you might have heard this somewhere. It is brute force algorithm. Okay, so brute force algorithm means most probably this algorithm we use in terms of cybersecurity, wherein when you want to hack into someone's account. Okay, so as a not a cybersecurity high, if you are an ethical hacker, you want to penetrate or you want to hack into the device of a particular uh, criminal. Okay, the criminal has been caught, and you want to hack into his mobile phone to check his what movement and all those things, to check his activities, what he has been doing. So or else you think that your friends, okay, you want to unlock your friend's mobile phone or friend's laptop. What you will be doing, the first thing you would be doing is you would put all the combinations of the password, what you may know what he might put it as a password, either his birth date or either his names combined with some other numbers. So all those combinations of the password you would try. So that is nothing but the brute force technique. Okay, so now here, what is the problem you have? You want to open the system. So how you will be opening the system? You have to know the password. To know the password, you need to follow some steps. Now that steps is nothing but an algorithm. Okay. Now which algorithm, which approach of algorithm you are using here? It is brute force technique. Okay. So brute force algorithm is nothing but it is a kind of exhaustive search algorithm. Okay, you will be searching all the possibilities to required solution. So that is, so the explanation says like this: the general logic structure is applied to design an algorithm. Okay, general logic. Okay, it's not a big thing, it's just a general knowledge. Like, I want to unlock a phone, I want to just know the password. So what might be the combination of the password? I'll just try. Sometimes it works, sometimes it fails. So it is also known for this behavior of this particular algorithm. It is also known as an exhaustive search algorithm that searches all the possibilities to provide the required solution. So such algorithm are of two types. Now again, in the brute force algorithm, we have two types of algorithm. One is optimizing. So finding all the solutions of a problem and then take out the best solution, or if the value of the best solution is known, then it will terminate. That is optimizing. Okay, so optimizing means what? You find all the solutions, upon that all the solutions you find a best solution. Okay, or if the value of the best solution you already know, then it will stop searching for a solution. Next thing is sacrificing. So as soon as the best solution is found, you are stopping. So optimizing and sacrificing, the two types of algorithm which will be included in the brute force algorithm. What is the second approach of algorithm? The second one is divide and conquer. Okay, what is there in divide and conquer? So it is a very common implementation of an algorithm. So if I'm talking about an algorithm, as our course is about DSA, correct, data structures and algorithm. Okay, here in algorithm, I want to say is about, okay, in algorithm, what I would like to say is it's a step-by-step process. We all know that. Okay. Now there are some algorithm which is working with this approach of algorithm, which is divide and conquer. Means first you divide the things into uh, half or different steps, and then you combine all them together. That is nothing but divide and conquer. So you are trying to conquer or trying to solve one problem, trying to conquer one solution by using divide and rule method. So that is divide and conquer algorithm. Or this approach of algorithm is divide and conquer. So now let's see this, what exactly it has to say. So it is a very common implementation of an algorithm. It allows you to design an algorithm in a step-by-step variation. Okay. So it will be having a step-by-step variation. First, what it will do is it breaks down the algorithm to solve the problem in different methods. Okay. One main problem will be there. It will break down the problem into two problems. So it allows you to break down the problem into different methods, and valid output is produced for the valid input, and this valid output is passed to some other function. So as in the diagram, so there will be a main problem. You divide it, okay, and from that you conquer whatever you want. Okay, for one problem you conquer one solution. Okay, solution of sub problem you get. Then for another sub problem you conquer the solution for it. Now what you do is you combine both of them. Okay, so you will be getting the, by combining this you'll be getting the solution for the main problem. So this is how divide and conquer approach of algorithm is working. Now, next thing is, the third thing is what we have is the greedy algorithm. So by the name itself, greedy algorithm says is it's very greedy. Okay. You get one solution, you get second solution, you get third solution. There are many different solutions out there. But out of that, you want to find the best solution from it. So that is a greedy technique. Okay. So it is an algorithm paradigm that makes an optimal choice on each iteration with the hope of getting the best solution. Okay, it always makes a very good choice, okay, on the each iteration upon getting what a very good solution. So it is easy to implement and has a faster execution time, but there are very rare cases in which it provides the optimal solution. It's okay, it's not like it will always give you the optimal solution, but it does its best to find the optimal choice. It makes its optimal choice in with the hope of getting the best solution. So here if I see, this is a kind of graph. Okay, so the starting point is here, this is a destination. Now I have three ways in which I can go. First I can go through the route of A, through B, through C. Now if I add their cost of the path, one is 20, one is 30, one is 3, one is 5, one is 1, and one is 79. So out of these three solution, which is the optimal solution, which is the B, choosing the path of B, because that would cost you less compared to other ways to reach to a particular destination. So that is greedy algorithm. Your greed is like you will always go for an optimal solution. Although you get the solution, you will go for the optimal solution. That is greedy algorithm. Next thing is about the dynamic programming. So dynamic programming means it makes the algorithm more efficient by storing the intermediate results. It is very dynamic. It is very quick. Okay. It's not like greedy algorithm. It's not like divide and conquer. It's not like brute force algorithm. It is greedy. It is dynamic programming. Okay. So these all come under your approaches of algorithms. So this are all very interesting concepts actually. So it makes the algorithm more efficient by storing the immediate results. So it follows 5 different steps to find the optimal solution for the problem. Here also there is an optimal solution. Okay, but this is dynamic. Intermediate results, it will efficiently store it. So what is the five different optimal steps to find the optimal solution for the problem? Is the first one, it breaks down the problem into a sub problem to find the optimal solution. Okay, as we have it in the divide and conquer, a problem will be there, you divide it into sub problem to find the optimal solution. After that, after breaking down the problem, it finds the optimal solution out of these sub problems. Okay, sub problems are there. Out of these sub problems, it will find all the optimal solution. And now the result stores the result of the sub problems, which is known as the memorization. So from there is a big problem, you divide it into two sub problems, and out of the sub problems you find the optimal solution. Okay, that can be your which one, greedy algorithm. Okay, after that, what do you do? It will be storing the result of that sub problem, which we call it as a memorization. Okay, and then they reuse the result so that it cannot be recomputed for the same sub problems. Got it? So that is dynamic programming. They will store the intermediate results. So if I say one problem is there, I'm dividing it to five sub problems. So I have got the result of two sub problems, and through the technique of memorization, it has been stored. Now the third sub problem is similar to the first sub problem. So what we will do is we will be reusing that result so that we don't have to recompute that particular thing for the same sub problem. So what happens is finally it computes the result of that very complex problem. So this is dynamic programming. Okay. Yeah. So in the greedy algorithm is what? We have many solutions. Out of that, it find optimal solution. In divide and conquer, what it does? The big problem, it will be divided into sub problem. Individual what outputs will be got or the solution will be got, then these will be combined together to get the solution for the main problem. But dynamic programming is not like that. There you can save the time because of the memorization technique, because if there are similar sub problems, you can reuse that result whatever is there to solve that particular sub problem. And there are two type of approaches in dynamic programming. If I say, one is using top down approaches, a big problem you divide it into sub problem and use the memorization technique. Another one is the bottom up approach, which is nothing but tabulation. So what you do, sub problems, many sub problems will be there. Okay, so each sub problems you first find out, then you do the tabulation, and then you entirely go up to the big problem. Okay, the concept. So that is top down approach and bottom up approach. So that is dynamic programming. And next thing what we have is branch and bound algorithm. Okay, so this we will discuss in the next class. So today we have seen four types of approaches of an algorithm apart from other concepts which we have seen. Okay, one thing is brute force algorithm. In brute force algorithm, what we do is we just use a general logic. Okay, whatever we know, just we type it or we just check in a way whatever we know. That's all. We don't do it in a very big algorithm. This is one of the exhaustive way, but also some of the simple way I can say. So that is brute force algorithm. Second one is divide and conquer. The problems, major problems, you put it in the sub problem. Then you find the solution for the sub problem. Then all the solutions will be combined together to get the solution of main problem. Third one is greedy algorithm. So it will, in each iteration, it will always find for the optimal choice. Okay, and the hope of getting the best solution. Okay, out of that, which will be less, which will be easy one, or which will be the optimal solution, it will identify that as a solution. That is greedy algorithm. Fourth one is the dynamic programming. So what happens here? A big problem will be divided into sub problems. In the sub problems, it will identify the result, the solution, how to solve it, and the results will be stored somewhere, which is called as memorization. And whenever you get some similar sub problems, you use the same result to solve that particular sub problem. Okay, so that you don't have to recompute it. Okay, then you ultimately at the end you will get the solution for the big complex problem. Okay, yeah. So that are the four approaches. We have few more approaches of algorithm that we will be discussing in the next class. So here we have learned about okay, in today's class we have learned about what is algorithm, what is the need for algorithm, the characteristics of algorithm. Then we have seen what is the data flow of algorithm. Like first there will be a problem, then there will be a algorithm you build, then input will be taken, be there, then processing unit, and then output. Then we have seen some of the factors which we consider in the algorithm, and then apart from the characters, we have seen the issues what we face during the building an algorithm. Okay, when we consider an algorithm, and also the importance, both theoretical and practical importance of the algorithm, and also finally the four different approaches of algorithm, including brute force technique, then we have greedy algorithm, then we have divide and conquer algorithm, and then we have dynamic program. Okay, so that's all for today. Thank you.